So, hello everyone. This is Martin from the Massimal project, and I wanted to share with you some results from the last test we did with a hyperspectral camera mounted on a drone. And this test was performed in Røvik, about 45 minutes by car outside of Bodø in Norway. Um, and this is an area with a very large kind of silt beach. Uh, and and we are thinking of studying this beach in our first research campaign, and so we thought we'd study it for the test as well, or while testing this hyperspectral setup. So we made this area that we wanted to image, and it turns out that this we weren't able to capture images for the whole area, but I'm going to show you some images that kind of span this shallow to deep end, as you can see here. And also in this image, there's no snow, but there was a lot of snow when we were working. And I thought I'd show you a couple of Facebook images to illustrate that. So this is the drone, and we just dug a kind of takeoff place in the snow. Uh, and on the drone, we have also mounted this spectrometer to measure the incident light coming from the sky and the sun. So I don't think I'll go into details about that now, but this is very useful to kind of take into account what kind of light there is for the scene at any given day. Um, and also, uh, we made some markers that we placed in a shallow part of the beach. So here you can see the kind of snow in the background and some bamboo poles. Uh, and I'll show you some details. So this is one blue marker that we put in the middle, and then we had four different kind of rubber mat markers around. So I was just curious if we would be able to see those. And this is Sigfinn who's flying the drone. All right, so now let's head to Spectronon, which is the software we use for viewing and processing hyperspectral images. And in this first image, you can see kind of the edge of a snowy beach here, and here the darker part on the bottom is wet sand, basically. And right now it looks very black and white, and that's because this snow reflects a lot more light than anything else in the sun in the scene. So if we click in this snow, we get the amount of reflected light in the unit of microflicks, and as a function of wavelength. And these blue, red, green, and red lines here, they indicate the wavelengths that are used to display this image over here. So it's kind of just extracting a subset of the hyperspectral image in order to show it as a color image here. And if we want, we can move those around, but we'll keep them like that. So let's say I click down here in an area that just looks black. We can see, okay, there is a spectrum here as well, but it's the values are much lower. And in order to actually see something here, we can adjust the contrast. So here uh, we have something called a linear percentile stretch, and that means that it kind of stretches the intensities of the shown image so that it uh, so that the kind of 2 percentile value corresponds to black, and the 95 currently percentile value corresponds to white. And so if we leave this as it is and then adjust this we kind of uh, cut out some of the higher intensity values and we see the lower intensity values more clearly. Boom! Oh, now suddenly all this snowy part kind of disappears. It all becomes white, but we see lots more detail here. So let's see if we can maybe zoom in a little bit. Let's see. Okay, I'll try to adjust that so it's slightly darker. And if I'm not completely mistaken, we should be able to see those markers. There they are. So they're not huge exactly, but they're here if you know that they are. So you see very small adjustments here means a very large change. But let's try to click on this blue dot here. We can see it has a huge spike in the blue part of the spectrum, almost nothing in the green and red part. And I have a yellow marker, so there's very little blue, but more green and red. And there's a red marker here. It's mostly red. So it turns out, even though these markers are not that big, I think the small ones were about 15 centimeters in diameter, and this larger one was almost 30 centimeters in diameter. Even though they're not that big, we can see them pretty clearly. So let's say every pixel is about 5 by 5 centimeters. Um, so let's adjust this to maybe slightly lower value and zoom out. So another thing that's interesting here is looking at the different objects on this beach. You have just a sandy bottom, looks like this, pretty flat, like about 350, 300 microflicks in all of these bands. And there's quite a lot less in the infrared up here, above around 750. However, if we click over here, which is I think maybe some fucus or some algae at least, not exactly sure, then we see, ooh, not that much reflectance in the visible part of the spectrum, but a huge value here in the infrared. And this is typical of all sorts of vegetation. and and it's interesting that we can see it so clearly. So this is parts that are not submerged underwater, but I think if I click around here, for example, uh, it's I think maybe it's dead vegetation. I'm not exactly sure. We haven't really studied the area yet, but we can see also for this shift, having this kind of red edge, I think it's called, uh, and it's quite easy to see also for this submerged and maybe dead or half dead vegetation. So that's interesting, I think. Now this represents a very shallow part of the beach, maybe just, I don't know, 20 centimeters of water. And here you can see some waves that's beginning to become a little deeper. Let's see. Sorry for the And here also we can click and see some, okay, then there's some noise kind of destroying the spectrum here a little bit. Let's see. So here further down when it's a little bit deeper, this red edge isn't that visible, and there's less detail in the spectrum. But there's still something there, still interesting. All right, so this is, if we zoom out, this is from the edge of the snow and the very shallow part. Now the drone was moving kind of from the top here and towards the bottom. So the next image in line looks like this. And don't be fooled by how bright it looks, because it's actually this top part here is just a continuation of what we saw in the bottom part here. So it's just this kind of contrast settings that make this look quite bright. But here we can see still these patches of vegetation, and there's kind of bright sand, and here we can really see there's pretty much nothing in the IR. Maybe if we zoom into some of those patches, you can see if we have any trace of that red edge still. Yeah, there is a little something here. And well, this lack of any infrared um, signal is, as I understand it, I'm learning about this, is due to the absorption of light in the water itself. So there are several different contributing factors, but just absorption of light in water is just increasing a lot from this edge of visible light and up towards the infrared. So we can kind of still see the difference between gray sand and vegetation. That it looks darker, but also has this kind of peak around 700 nanometers. All right, I won't go into the lots and lots of detail. But here you can see it becoming more and more deep. So here, let's see, in the deeper end, we have even a bit less light, and it's all kind of blue and green, and you're losing also this most of the red as it's shown on the image at least. And now if I try to click in one of those darker spots, I think we can still maybe see small traces of something, a kind of red edge here, maybe. But it's really just coming down to towards the noise floor. Um, and now we can even go deeper. We can look at the next image, and that looks like this. Um, and now I, I I no longer really know what we're seeing here. We need to, I guess, survey this more. But you can see there's the kind of shift from sand to some kind of more heterogeneous bottom here. So you have this type of area with this kind of spectrum. Let's see. Can I just save that? Sorry. Add it to the workbench, as it's called. And then there's this more slightly darker area here. Okay, it's very much the same shape, but lower intensity. And okay, even darker area and even a little bit lower intensity here. So we're working with a very weak signal here, but I'm actually positively surprised by um, how much we're actually seeing. I was thinking that this will just be black more or less. When you're looking at it from the from up on the surface, you all you see is reflected sky pretty much, and here we actually see a lot of patterns. So that's interesting. Finally, I wanted to show you all these three images just appended together. Let's see. And it just looks like a very narrow stripe, but it may give you some clue of what a larger image could look like, that you have this um, starting up in the shallow end. You're seeing this, what's the word, intertidal algae that are partly submerged and partly above water, uh, moving into slightly deeper area. You have this kind of distinct shift here, kind of, and then a darker region again, and then coming into this kind of patchy region down here. So, well, I find it interesting, and I'm looking forward to making actual diver transects that will kind of give us the answers for what exists underwater here. All right, that's a little taster of our data. Thanks for watching. If you if you're still with me.